In this lesson, we will learn the reasons why Active Directory is implemented in multi-master model, but it still requires flexible single master operation roles or FSMO. First of all, we will learn how multi-master model works in Active Directory and its last writer wins algorithm. After that, we will learn the reasons for flexible single master operation roles, and finally, we sum up the lesson with the keynotes. We usually hear Active Directory is implemented in multi-master model. What does this really mean? To understand that, let's take a look at this Active Directory domain it-skills.local. In this domain, the system administrator can log into any domain controllers to make the change. For example, he logged into DC01 and create a new user object with the username as user A and the department as IT. As soon as the user A's object is created, Active Directory on DC01 detects the change and replicates the user A object to DC02 and DC03 based on the replication schedule set on DC01. So multi-master model simply means a change can be made from any given domain controllers. The change then will be replicated from the domain controller where the change is made to all other domain controllers in the ID system based on the replication schedule. As you can imagine, the multi-master model introduces the possibility of conflicts as it may take time to replicate the data from one DC to all other DCs. Let's take a look at this example to see how Microsoft solves the problem with the last writer wins algorithm. In this Active Directory domain it-skills.local, let's assume this system administrator logged into DC1 and update the department of user A to network, and it also updates the timestamp of the change on the user A object on DC1. About 2 seconds later, this system administrator logged into DC2 and update the department of user A to networking, and it also updates the timestamp of the change on the user A object on DC2. Now the change on DC2 is replicated to DC3. DC3 checks the timestamp of the change and it finds it is newer, so it updates the department of user A to networking and it also updates to the same timestamp. Next, the change on DC1 is replicated to DC2 and DC2 checks the timestamp of the change and it finds it is older, so it discards the change. Now the change on DC2 is replicated to DC1. DC1 checks the timestamp of the change and it finds it is newer, so it updates the department of user A to networking and it also updates to the same timestamp. Finally, the change on DC1 is replicated to DC3 and DC3 checks the timestamp of the change and it finds it is older, so it drops the change. In the next replication, all the timestamps are the same, so no change is made. As you can see in the last writer wins algorithm, the timestamp of the last change is saved on the objects, and the timestamp will be sent along with the change and used to compare to determine if the objects will be updated. As you can see, the last writer wins algorithm is easy to implement but may not be feasible and efficient in certain cases. Let's take a look at this domain it-lifeskills.local. Now we deploy two new servers, DC04 and DC05. Let's assume this system administrator logged into DC04 and promote it to the domain controller of the domain hq.it-lifeskills.local, and it has this security ID. At the same time, this system administrator logged into DC05 and promote it to the domain controller of the same domain hq.it-lifeskills.local, but it has this security ID. As you can see, now we have two domains with the same names but different security IDs, and many child objects of these domains can be created with different names and different security ID before the conflict is detected. Therefore, the last writer wins is not feasible in this case because it does not prevent the duplicate name from being created, and it does not prevent the child objects of the conflicting container objects from being created and replicated. To prevent conflicting updates in such scenarios, Active Directory only allows a single domain controller assigned with a specific role to perform updates to certain objects in a single master fashion. For example, to solve the problem with creating duplicate domains, only one domain controller assigned with the domain naming master role in the root domain can create new domains. Schema update can only be performed by schema master role in the root domain, or only related ID master can provide related IDs to other domain controllers of a domain. Password change, time, and other types of updates are assigned to PDC emulator, and only infrastructure master role can perform cross-domain group membership updates. This is the end of this lesson. Let's read the keynotes.